Hello everyone. In this video we will be learning about normal distribution. It is a normal density curve. It is also called as bell-shaped curve. And this distribution is discovered by Paul Gauss. So that's why this is also known as Gaussian distribution. It is also known as Gaussian distribution. Normal distribution always cluster around central value, that is mean, which is always located at the middle of the curve. Let us consider an example of height of persons, heights of the students. So most of the people are of average height, and the number of people who are taller or shorter is a very small number. If we consider the range, let's consider this is the height of average people, and very few are smaller in height and very few are taller, and almost it is equivalent. The high smaller and taller people are almost equivalent. So this type of distribution is called as a normal distribution. So we can add few more examples like weight of a baby at birth, then daily rate of returns, for a stock market, weekly sales we can consider, yield of a fertilizer, and lifetime of bulbs. So these are the real life examples where these variables follows normal distribution. Okay. Now coming to the notation of normal distribution, it is denoted by capital N mu sigma square, where mu is the mean and sigma square is the variance. That is, sigma is nothing but the standard deviation. So we can say that normal distribution is described by the population mean mu and standard deviation sigma. So larger the sigma, the most spread of the distribution, that is the curve gets flatter, and if the curve is with more peak or height, then the sigma is smaller. So here in the first case sigma is large, and in the second case sigma is smaller. Now coming to the properties of normal distribution, properties of the normal distribution. Here, as we know, this is most commonly used distribution, and the shape of the curve is a bell shaped curve, and it depends upon standard deviation. Standard deviation sigma. And if we observe this curve is symmetric about mean. This line, if we consider, it is a central line, or we call as line of symmetry, and this central line represents mean, and in this case mean is nothing but it is equal to median and equal to mode, and this horizontal line extends from minus infinity to plus infinity. It extends minus infinity to plus infinity, and it is, as it is a density curve, the total area under this curve, the total area under this curve is nothing but it represents the probability, and always it is equal to 1, or that is 100%. And one more property is it is a unimodal, means only single peak we can observe here. For example, we can consider normal distribution with mu is equal to 160 centimeter and sigma is equal to 3 centimeter. And one more thing here, if we observe this normal distribution, this horizontal line never touches this curve. It goes up to minus infinity to plus infinity. So if we consider mu as 160 centimeter and sigma as 3 centimeter, so if I draw a symmetric line, it means that here mu is equal to 160 centimeter and as sigma is 3 centimeter, so I have to add sigma to this mu, that is 163. This is mu plus sigma, then 163 mu plus 2 sigma, this becomes 166, then 169, and this side mu minus sigma, which is 157, mu minus 2 sigma 154, and mu minus 3 sigma, it gives 150. So almost all the points are between 151 to 169, that is mu minus 3 sigma to mu plus 3 sigma. That is the students are having, if I consider heights, students are having height between 151 centimeter to 169 centimeter. But if you can observe here, the curve extends up to minus infinity to plus infinity, minus infinity at left hand side and plus infinity at right hand side. So these are the important properties of this normal distribution. Moving ahead with the empirical formula, or 68, 95, 99.7 rule. So let us consider the distribution again. As we know, this mu is the center line. Center line represents the mean, and this is mu plus sigma, mu plus 2 sigma, mu plus 3 sigma, and left hand side mu minus sigma, mu minus 2 sigma, mu minus 3 sigma. It means that if we have a data points collected, then 68% of the area under the curve lies within one standard deviation. This is one standard deviation or first standard deviation. If mu is the mean and sigma is the standard deviation, then what we can say, 68% of the values fall in the range mu minus sigma to mu plus sigma. Approximately 95% of the values lies within two standard deviation of the mean. So it means that if we consider heights, so there would be number of students between the students having heights between mu minus 2 sigma to mu plus 2 sigma is 95%. And similarly, last one is 99%, 99%, or approximately what I can say, 99.7% of the values lies between third 3 standard deviation or 3 sigma. So that means 99.7% of the students height is between mu minus 3 sigma to mu plus 3 sigma. So this is the one of the important rule which is called as empirical formula, or the rule 68, 95, 99.7%. Thank you.